All right, so now we're going to talk about what happens when you plug each of these solutions back into their original equations. So I'm going to start with number 8. So on number 8, we got n equals 2/5, and we got n equals -1. And so I'm going to start by plugging in the -1. And so I'm going to put a box over here to do that. And so when I plug in n equals -1 to the original equation, 1 minus 6n plus 3 equals 4n. Oh, not n. We're going to plug something in. Plugging in -1. Okay, so on the left-hand side, -6 times -1 is +6 inside the bars. And so we end up with absolute value of 7, which gives us 7, which gives us 10 when we add the 3. On the right-hand side, we do 4 times -1, and we get -4. And so because 10 does not equal -4, this n equals -1 cannot be one of our solutions. And so even though we did the correct algebra to get to n equals -1, it still doesn't work. And so n equals -1 is what we call an extraneous solution. And so the Algebra 2 standard says you can identify extraneous solutions. And so on your paper, you would need to cross that off and just say EXT. You don't have to write out the whole word. EXTSOL. That's how you're going to show me you can identify extraneous solutions. And so extraneous solutions are solutions that you get from doing all of the algebra, but when you plug it back in, it doesn't work. Okay, that happens with these absolute values bars that have a variable on both sides. Because what's happening is on the right-hand side, this 4n, it's a line with slope of 4. While on the left-hand side, we have an absolute value. Okay, and then when you take the bars off and write these two cases, you're acting like you have two linear equations. And so you can come across solutions, intersections that aren't actually there when that happens. And so that's where these extraneous solutions are coming from. And so I'm not going to put you through watching me plug in the 2/5 in the other examples, but 2/5 actually doesn't work either. And I'll let you verify that on your own by plugging it in. Okay, in the case of number 7, when you plug in this 4 and when you plug in this -12/5, they both work. And so those are actual solutions, whereas on number 8, we had two extraneous solutions. Okay, whenever you're running into these two solutions, you could have one of them be extraneous, you could have both of them be extraneous. You never know what you're going to get unless you go through this work over here that I did in the box and plug it in. Okay, so plug those back in and you'll see that 4 and -12/5 do satisfy this equation, whereas if you plug both of these solutions into number 8, they do not satisfy the equation.